Okay, so we're going to start on lesson 34, the stoichiometry lesson. I will put all of this up on Google Classroom, put all my answers up on Google Classroom. You need to make your way through the notes themselves. This is the PowerPoint. And then these are the examples that are in the notes right here, these two. These are the two that I'm going to do for you right now. Okay? The gist of stoichiometry really is, and you'll hear it called stoic all the time from hardcore chem people. I don't know. But anyway, is that you're taking everything you've learned so far and you're putting it all together in one. Okay? So your question in the example is how many grams of potassium chloride are produced from the decomposition of 668 grams of potassium chlorate? Okay. All kinds of stuff you got to know here. So the very first thing I like to do is figure out what it is we're looking for. It's asking for grams of potassium chloride. So I always put need there. Okay. The type of reaction probably will be given to you. It is decomposition. Decomposition means that's one thing, like AB yields A plus B. Okay. It's potassium chlorate, so when it falls apart, it doesn't exactly fall apart into its component parts, but we've seen this one before. 668 grams of potassium chlorate is what we're given. So you'll see I underlined it, and I wrote given on it. Okay? All right?
Sorry, yeah.
Okay. All right. So the very first thing you're going to do is write and balance your equation. Very first thing. Right after you figure out, the first step, obviously, is read the problem. Second step is always figure out what you need and what you're given. And then the third step really is write and balancing your equation. Writing and balancing. So you can see here that I did 2 KClO3, whoops, is decomposing. Okay, this is potassium chlorate. Again, you have to be here, meaning you have to be able to do this. You have to know that that is potassium chlorate. Potassium, chlorate, you know that's chlorate because it's polyatomic ion. You know there's one potassium because chlorate is -1. Potassium is +1. You already know that stuff, okay? Now, when that breaks down, it's going to break down into potassium chloride and oxygen. You know that because you've seen it before. This is all about experience, okay? But the thing is that one of the things that is that let's just say you didn't know that. Let's say you weren't paying attention and you missed this or you didn't do this one or whatever. But watch this. When we go back up here to the example, it asks how many grams of potassium chloride. So you know that has to be one of your products, okay? So potassium chloride has to be a product because it's what you're looking for. The only thing you have left is oxygen. When oxygen is by itself, it's always O2 because it's a Broncliffe. It's a diatomic molecule. Again, something you should already know. So, balance. First of all, this is your decomposition reaction. This is falling apart into these two things. Balance. You have 3 oxygens here, you have 2 here, so I'm going to go to 6. So I'm going to put a 3 here and a 2 here, which then means I need to put a 2 there. Now, I did that quite quickly. The reasoning behind that is because you should know how to balance an equation. So, now, from here, you got to make a stoic plan, a stoichiometry plan. Okay, if you come up here and look, I'm given grams, okay? We're given 668 grams of potassium chlorate, okay? So we have grams. Obviously, we got to go to moles. From moles of potassium chlorate, we're going to go to moles of KCl. From moles of KCl, we're going to go to grams of KCl. I always like to make a plan, so let's go over here and write it down. We have grams of KClO3. We can go from grams to moles. We know how to do that. Again, you had to have been paying attention. So moles of KClO3. From moles of KClO3, we're going to use this balanced equation to go from moles of KClO3 to moles of KCl. There's a 2-to-2 ratio there. Take a moment and make sure you understand that. There's a 2-to-2 ratio between KClO3 and KCl, okay? So from there, we're going to go to moles of KCl. And from moles of KCl, we're going to go to grams of KCl because that's what it's asking for. So this is what you need. this is what you're given. Okay? So now watch. You're given 668 grams of KClO3. Grams to moles. We've been doing this for what seems like 20 years. 1 mole KClO3, 122.54. I guess I have 5. It should be 5.5, but whatever. Grams of KClO3. If you don't know where I got that number, you need to go back and check your notes. Okay, so grams of KClO3, moles of KClO3. Now here's where this whole thing, all comes to fruition, what we've been doing all this time. You have 1 mole of KClO3, but there's a 2-to-2 relationship between KClO3 and KCl in the problem. So what you're going to do is you're going to put 2 moles of KClO3 down here, and you're going to put 2 moles of KCl on the top. That means your moles of KClO3 are going to cancel, and you're going to be left with moles of KCl. Now, this is a 2-to-2 ratio, so this is going to turn out to be 1 anyway. But do it anyway because your units will make more sense, okay? The way we got this 2-to-2 ratio, again, is from our balanced chemical equation, okay? Our last step, and I'm running out of room here, is 1 mole KCl and 74.55 grams of KCl. Again, if you don't know where I got that number, you need to go back, okay? Now we just do our math. We have 668 divided by 122.55 times 2 divided by 2 times 74.55. We get 406 grams of KCl. We go with the same number of significant figures as we started with. So it's 3 and 3. And that's how you do it.